Assalamu alaikum everyone. Welcome to the AI Bootcamp Day 2, which is conducted under the supervision of Microsoft Learn Student Ambassador Lahore, led by Saad Aslam. Um, as we have scheduled 2 sessions for you today, the session 1 is going to be delivered by Alexandru, who is going to talk about the Microsoft AI bringing solutions to your solution. First of all, I would like to thank the societies we have with us who collaborated us. IEEE CNAID student branch, secondly IEEE UCP student branch, IET Concepts Lahore, and IEEE Women in Engineering Lahore. We would love to thank all of these societies who collaborated with us to bring these sessions for you. This is the day 2 and also the last day of the boot camp. We have a speaker Alexandro. I'm going. Uh, I will tell you about a little bit introduction about Alexandro. He is the computer engineering student at University of Belgrade, Serbia, GCDC lead at University of Belgrade of 2021, ex-machine learning intern at Microsoft, experience with deepfakes, FPGA programming, operating system, and web development. So I would love to call Alexandro and to represent his slides and sessions for all of you. Thank you.
Yes, I'm going to add something. Like Alexandra is the AI MVP. He's the Microsoft certified trainer. Uh, he is Gold Microsoft Learn Student Ambassador and the country lead for Romania, technology and AI. As can be seen from his technical and academic achievements. So I request Alexandra to start his session. So Alexandra, can you start your session?
Thank you. So can everybody see my screen? Can you see my screen?
Just a minute. We can't see your screen, Alexandra.
Okay, let me try it again.
Yeah, yes, you can share it again.
Can you share it now?
Yes,
This
you
is
can see
desktop.
now.
Okay, and now the presentation.
Yes, we can see.
Okay, thank you. Thank you for your kind introduction. This is a slide for me and some of my achievements. If you have any questions, you can stop me. But I have taken about 15 minutes at the end for any question that might pop up on the presentation or over some related subjects. So if you think your subject is strictly related to the current thing that I'm presenting, stop me and ask. If not, please hold it until the end because we have time, especially for that. I'm going to tell you some things about AI, and I'll start with my goal. AI in general means I have to teach the machine how to solve a specific task because I'm a little bit too lazy to do it, or I have to do it again and again, and I don't want to, but I still have to do it. So, in general, AI helps us automate tasks and deliver, let's say, better content for some specific scenario. We'll see in the slide some examples. But in general, AI helps us automate some tasks or help us do some tasks that is really well defined. First of all, those are some really big companies that are doing AI. So it's not only Microsoft, also Facebook is doing AI, Amazon is doing AI, IBM is doing AI, Oracle is doing AI, Baidu is doing AI, Google is doing AI, a lot of people are doing AI. But I'm going to focus on the Microsoft area because I'm a Microsoft MVP, but also because I think they have some services and some products for all types of people, not necessarily hardcore developers, as Facebook has, for example, PyTorch or Google TensorFlow, but they have artificial intelligence that can bring intelligence to your solution at pretty much any level. So this is from their side. Why Azure for AI? Basically because they are offering the core functionality of cloud provider. So the security, the scalability, the compliance, and so on. That's like the start point. Then they offering services at their enterprise level, which is also really important because maybe it's good for a startup to have some quantity or some quality of service. But when you'll have to scale, you still need to maintain your compliance for your partners, your clients, so on and so forth. So that means you either have to manage it yourself, which you'll need separate infrastructure, you'll need people, you'll need key people. But basically, if you're taking a really big cloud supplier, that means they're taking a lot of responsibility out of your hands, and you'll only use some services. Another reason why you should go or you can go for the Microsoft Azure AI stack is because they're offering services in pretty much all AI. That doesn't mean necessarily they're the best at everything, but it means it's a really good option. Also, since it's the Azure stack, it means it binds really well with other services. So you can use AI native in web apps, you can use it in mobile, and so on and so forth. Those are some really cool partners that are using Azure AI. So they even have Accenture, which is some part of, let's say, adversary for some topics. But in general, they are really delivering good AI components. And now I broke the, let's say, most important services into three categories: easy to use but powerful, which are video indexer, Azure Bot Service, custom vision, and Q&A maker. With knowledge comes power, meaning you can have like standard sample or out of the box usage for cognitive services, cognitive search, and language understanding unit, which means you can either have a product solely using them, or you can combine them in more interesting things where you can customize the services, because you can also train them outside of their scope to get better insights from them. And now there is some more interesting topic called Azure ML, which gives you a lot of features that can help you build pretty much anything. But then again, this requires more deep knowledge because they're offering you some tools, but the main job will be for you to use them. In other cases, basically, you're just consuming services or using portals. With Azure ML, you have to build a lot of stuff for yourself, and you have to have the knowledge, because they, let's say, just give you the small Lego bricks. You have to build the tower yourself. In the other casing, they're basically giving you towers, they're giving you cars, and say, okay, you can have to build your city. But with Azure ML, let's say you start small and then you grow yourself. Right now, what I'll do, I'll walk through each one, and I'll give you a scenario of what you can do with it and how you can enchant it. Let's start with Video Indexer. Video Indexer is a really cool tool which has its own platform, so you don't necessarily need to access it from the Azure stack, in which you load the video and then it starts to analyze it. Some really cool thing is that it uses more complex, already built-in tools like cognitive search, cognitive sentiment analysis, key phrase extraction, so on and so forth. What it will do, it will analyze your video end to end. It will recognize people. It will recognize topics. It will recognize a lot of interesting things. And it will go from macro, meaning what is the most discussed topic in this video, to micro, which means, okay, when was the word Java mentioned in this video? And you'll see Java as a spoken word. You'll see Java as a logo with image recognition, and you might even see Java is some hidden word or some logo somewhere in the background, and it still be recognized. What's really interesting, because with this you can get insights. You can also track people if they are public figures, like Satya Nadella in this example. They'll be also matched with the database, but you can also recognize different people and tag them, and you can see when they appeared. So, for example, this is from Ignite 2016. And they recognized a lot of people in this video, and most of them were. Can you please mute your microphones? Thank you. And then It also provides you insights on emotions based on a combination of audio and video. Basically, it will manage to recognize some emotions from the text that is transcribed. It will manage to recognize from the tone and also from the look of the face. So it's a combination of 3 core services: sentiment analysis from text, sentiment analysis from voice, and sentiment analysis from images. So this is a more complex service which analyzes things. It has an API, so you can load programmatically videos inside it and analyze it. So if you're having now let's do a product idea, which I also saw at the hackathon. You want to analyze content to see if it's fit for a category of people. Let's say, I don't know, you want to make you want to filter some videos for children, for small children, and maybe not all the content is adequate. So you run all your video feed through this service and see some keywords, you see some emotions, you see some information transcribed, and based on that and some custom filters, you can say pass or under review or denied for a video. So you can use it to filter your content. Another thing would be to give you insights about your, let's say, social media presence. You have a company and you want to see how the public may react to your video. So you can do a pre-screen running to the video detector and see some statistics from your video before publishing it to the people. So you can have like some initial feedback from an automated machine to see how your audience may react. So this is a really, really powerful service. Another cool thing is the bot framework. For those of you who don't know, there are a lot of bot frameworks in the outside, not necessarily from giants like Microsoft, Facebook, and so on. You can also build bots with pure Python. So there are a lot of packages which build bots. But what's cool about Microsoft Bot Framework is that it already has integrated a lot of services and a lot of ways of communication. So for example, you can release it connected to Teams, to Facebook, to WhatsApp, to SMS, and so on and so forth. The basic principle of a bot is the interaction, the way it interacts. Basically, it will listen to a channel, and then it will come to your logic, and then it will respond or should interact. So basically, it's like a question answer system in which you have to adjust the logic. They will make sure they're listening for the questions, and then you should provide the answers. You can also build your custom connectors in order to make it work with more services. It's growing really fast in Azure. So there, I think right now at least 20 providers. So you can connect a lot of stuff. Even WhatsApp right now should Twilio. With this, there are a lot. So pretty much any chatbot that you can think of on pretty much any platform. Okay, so you can build a full chatbot with those. It is running under an ASP.NET Core MVC architecture. So basically what you're going to get is a controller and some overloads over that, which means you're deploying on a web application and then you can use it in your Azure on-prem site. What you need outside that resource is a specific resource, which is the channel resource for the bot. And after that, you can use it. And the bot can even act like a person in Azure Active Directory. Another cool tool from Microsoft is Custom Vision. Again, this one has the portal. Bot Framework doesn't have a portal anymore. It's in Azure. It's a resource, but this one has a portal. It's a really interesting tool from Microsoft because it allows you to build complex models, computer vision models, using pretty much just your mouse. Right now, it's specifically for classification and detection tasks, but it has some interesting models which are state-of-the-art and they have state-of-the-art performance. And the really cool part for those of you who know computer vision is that you can train this model with at least 15 images per class. So in order to make a model that has 80–90% accuracy on a class, on a classification task, you need 15 images. While, I don't know, using TensorFlow, using PyTorch, using Keras, using, I don't know, anything, you probably need thousands of images, let's say at least 5,000. So with this cool trick, you can start with 15 images for a class and then build a
Alexandru,
classifier. Yeah.
can you please share your screen? Your screen is not visible right now.
Okay, I'll share it again. Okay, sharing it again. Can you see the presentation?
Yes, we can. Yes, thank you.
Thank you too. So this tool is really interesting, and maybe we'll have time to go through it because you can either build complex models which run in the cloud, which basically need the cloud infrastructure, or you can also build compact models which can later be packed and deployed on smaller devices, for example, a Raspberry Pi. So you can build a model that a neural net that runs on a Raspberry Pi at really good performance. Microsoft is providing all those out of the box. It also needs a cognitive services resource, so it needs a, let's say, Azure backend. But then how you deploy the model, it can also be on-prem, or it can be kept in the cloud. It has a RESTful API, so you can connect to it and submit tasks, so on and so forth. You can choose the time of training, so it can be either a quick train, which takes from 3 to 20 minutes, or you can make advanced trainings like configuring Otaml, and we'll get to that also, where you say, okay, train for whatever, at most, I don't know, 10,000 epochs, 5,000 days, and then wake me up, send me an email. So if you want to go 1 month in vacation, you can set it up to run a lot. And then once it's done, it will send you an email saying what are the results. And then you can go in the portal and analyze it, which I think is really cool. Now, this is for Q&A Maker. What's basically doing is a special knowledge center. So basically you'll edit knowledge documents, Word, PDFs, PowerPoint, Excels, whatever format they're accepting in a specific format. So they have some guidelines and some samples for documents, and then it will learn from that knowledge base and will be able to answer basic questions. So instead of having a frequently asked question page on your site, you can even have a cool Q&A Maker bot, which allows the users to ask pretty much basic questions in natural language, and then the bot will be able to answer those. Aside from learning from the base, so it can learn from documents, you can also train to answer specific questions like that one, for example, what are your hours today? You can either give it a schedule, or you can train it on that specific type of question with some variations, and then it will be able to answer your questions. So this is a really cool first line support bot, meaning you talk with it, and then at some point you either say, okay, I'll give you some normal person, or the user should invoke the normal person if needed. I think you all know support bots. Basically, they will answer the most common questions, and surprisingly,
Alexandru,
this also.
sorry to interrupt. You can please share your screen again. There, someone is interrupting the screen.
So anytime they're taking away my share screen, please intervene, and I'll share it again. Thank you. Luckily for you, I had that in mind, and I made a really simple presentation, so I'll stay on each slide probably 5 minutes. So I'm not going to make a lot of changes. If we have time, probably I'll walk through the sites, and then at that point, it's really important that nobody takes the screen, because then you kind of need to follow. So to recap, Q&A Maker is really cool for making first-line support bots, because they will answer the most frequent questions, and sometimes that's all the user needs. For example, I went to a website about my mobile data connection. I couldn't find the information on the site because it was not necessarily not well presented, but I couldn't find it. It wasn't in my search pattern. But then when I asked the chat with someone, Plot, I managed to find my question in like 2 questions. I asked 2 questions and then I found the information I needed. So I saved someone's time because some people probably lost 2 minutes with me and someone more important task could have been done. Now moving to more interesting sides is the Cognitive Services Toolkit. It's growing, let's say, each month. So each month there's a chance that a new service might appear, a new server might rise in beta. This is not the latest picture because they also have anomaly detection, and I don't know in which subdivision is, but basically they're having the core cognitive functions. That's how they named it. It's named Cognitive Services because they are trying to serve each task of our cognitive functions. So decision, speech, language, vision, search, detection, personalization, stuff like that. They're trying to give us services in order to code custom tasks. For example, in the decision toolkit, at some point it was the anomaly detection. Basically, let's say for the heart rate or sleep patterns, it could detect when you're resting best or when you're not resting best based on some known patterns and then based on enough data. Those also work with small data because they're built to be services. So the moment you use it, it's a RESTful API or it has an SDK. The moment you use it, you just use it. Some of them have also trained features. So for example, in the speech toolkit, when you have speech to text, you can also train on custom words, company words, for example. It knows how to recognize Microsoft, of course, because it was trained by the people of Microsoft. But if you have a newly built company, you might want to train it on how it's pronounced in order to be recognized as a proper noun, not necessarily as the closest word that it can get. The speech SDK is really cool because it works with a lot of languages and they're adding support for more and more languages. Sadly, my language, Romanian, is not necessarily supported, but they're adding more and more languages, which is a really complicated task. For those of you who don't know, the speech-to-text translation, it has multiple approaches because you're binding to words that you know, and you're considering those keywords and you try to guess the context because it's a complicated task. You can't necessarily translate each sound because each language has its own phonetic rules. And that means you can't necessarily translate each sound and then see what the text is. Basically, you have to pick some words that you know will be there. For example, in English, you have a lot of D, I, M, so on and so forth. So you basically find those and then you try to guess as much as you can and then make sense based on a context. So that's really cool. You also have language understanding toolkits. Sentiment analysis is one of them. You can also have keywords extraction and stuff like that. In the vision toolkit, you have the basic computer vision tags, recognizing, is it a landscape? Does it have a subway? Are there people? How's the weather? That's basic. Then you also have a specific toolkit for people. You can guess, and is it guessing better and better the age? Is describing people as it can also describe scenes. But cooler for the vision toolkit is that you can build it to recognize people, meaning is it the same people? So for example, if you have an app and you want to build face recognition, it might be complicated to build your own model. But you can use the Cognitive Services Vision Toolkit in order to make facial recognition based on the picture sent from the user. It will start with some training features. I think 6 is the minimum, so you can train. And then it will send another picture and just recognize. I don't remember which service Uber is using, but I remember that I wrote on an article that they're using the service. So they're using the service for someone. They didn't make a specific model for facial recognition, you know, when you identify yourself, which is really important to know that you don't necessarily need to reinvent the wheel. There are a lot of services on the internet that can help you at, I don't know, cheap to enterprise level prices and compliance. Another cool thing in the toolkit is the search function. They're using Bing search for pretty much anything, either a wide search, like what's this term, to, okay, give me restaurants, give me cinemas, give me people, give me news, give me anything. So they're using a lot of Bing search capabilities in the search toolkit. More interesting is that you can combine a lot of services. You can combine a lot of services because they're built that way in order to build a more powerful solution. They are getting more and more projects on the combination of data. For example, combining SharePoint documents, so your company's own SharePoint documents, with a specific knowledge base. So they ask people in charge to provide a database for basic knowledge. Who are the key employees? What's the hierarchy? What's the information? Also reading the emails and then combining all this knowledge will result in, for example, Cortana asking you each day that, okay, you had this chat on Teams. Was it a task? Did you solve it? And stuff like that. For those of you who are using Microsoft ecosystem in their day-to-day work, not necessarily multiple toolkit, but at least Office and Outlook for Teams, you'll see that they have a lot of powerful features which are enriched by your data in a non-targeted way. So the models are not necessarily trained on you. They're trained on general data, so they are not invading your privacy. But then the models are specialized for each people, so they will know that, okay, someone talked with you in some way, which means that might be a task. Then it won't take the information and build a model on yourself, but based on its knowledge from all the people. That's how you make a task. It will take that tokens from the sentence, and then it will say, is it a task for you? And then you're fine, and you're also helped. Another really interesting service, which is a little separated from the cognitive toolkit, it's language understanding service, Louis. As simple as it sounds, the language is really complicated when you have to explain it to a machine. If you want to think AI in depth, think about having a small children and then explaining to it more complex subjects, because that's what we want to do. So for example, 2 tickets from Cairo to Seattle, from this proposition, it managed to understand that, okay, the intent is that I want to book a flight. The source should be Cairo and the destination will be Seattle. And the quantity of those booked flight will be 2. So with this tool, you can train it on a specific set of questions. And then based on those questions, the model will manage to understand some topic, will manage to understand some structure, will manage to understand behind the scenes a pattern in how we ask questions. It's really important to give it more and more examples. Each language has its own capabilities, so you can train this model in multiple languages. It doesn't necessarily have to be English. So each one should know the language and the perks. But basically what you're doing with this is that you're helping the machine understand natural language more than the standard, I don't know, did the people say this word in the sentence? So string that contains? No. You're making it understand general language because you'll give it some alternatives to way of asking questions, and then it will manage to understand different entities. So for example, here it understands an intent entity, a source entity, a destination entity, and a quantity entity. So basically what you're trying to do is create some entities like those, and then give it enough examples to understand how it can recognize those entities in a normal question. Now, here's the fun part. Here is the Azure ML. What you see in the picture is the basic pipeline, the basic workflow for creating a machine learning model. Basically, you're going to train a model, package the model, validate the model, deploy the model, monitor the model, and then redo it again after some time. For those of you who know about Tesla or read a little bit about Tesla, you know that they have a continuous feedback model, which means that the more you're driving your car, the better it gets, and the more you're driving Tesla cars, the better they get. Because what's happening, Tesla is keeping the images of your drivings, let's say, let's call them like that, and at some point they will upload them to their cloud, and they will retrain the model. Basically, they don't need the engineers, or at least that's what they said, because the models at some point they re-update based on how was the road, how was the trip, how you adapted to the road, how the Tesla adapted to the road, because it's really important. Because it either needs validation that you let the car drive itself and it drives well, or worse, that you let the car drive and you have to basically take the wheel, which means the model really needs an important update. And now let's start with each part, because this is a whole section. What we're going to do in training the model using Azure ML, you have a lot of options. So the ML package from Microsoft comes with keys to a lot of services. The simplest thing you can do is Azure Notebooks, which means you'll have a Jupyter notebook saved on cloud, and you can use virtual machines to run those resources. So that's really cool. Maybe you don't have a powerful enough laptop to run ML. You basically just need an Azure subscription, and you'll be able to use that VM specially configured, so it's not a standard VM. It's made specifically for notebooks, and you'll use that compute VM to run your notebooks. For those of you who are Microsoft Learn Student Ambassadors, it's really cool and you want to learn AI, because you have about $150 each month. So you can use that old credit to get VMs for your ML models, which is really cool, I think. Another option, a little more advanced, is to use their ML Studio, in which you can build models with a combination of drag and drops and code. So you have some predefined models, like example, feature extraction. You can have word embeddings with more simple or complex embeddings. And then the standard models like super vector machines, linear classifier, logistic regression, or if you want to go hardcore, you have the most powerful module meant and named Python or R module, in which means, okay, you write your code. So you can start with a simple feature extraction. You don't want to write Python just to separate your columns, just to tokenize and stuff like that. You use a module with drag and drop to just configure it. But then you want to build a more complex model than it has. So you notice, for example, you don't have cascade SVMs. You have just simple SVMs, and it's a little bit too complicated to use modules to make a cascade SVM. So what you're going to do is going to import the module and then use it in order to work. You'll have to write Python. The only thing you need to match is the input of the module and output of the module. But that is really simple. Which is really cool with those is that you can either combine classical modules, which you know from the literature, and just drag and drop them if you don't want to write Python for those. But then if you want to get into deeper knowledge, you can use those. Another cool thing with ML Studio is that you can make really easy a RESTful API out of your model. So instead of going with Flask or any other tool for web development with Python, you can use Azure ML to build your model or load your model, because you can also load models with Pickle or Pipeline, your choice. And then you just select them with a receive input and a send output to an API, and then you made the RESTful API out of your model, which is really cool. For that, I have a GitHub repo if you want to look into. And then to more complex or more interesting, in my opinion, tools, you have a thing called Otaml, Automatic ML. There are a lot of frameworks for that, I know. They're open from sklearn. There are more and more modules coming. Google also has one. Microsoft also has one, and is this in this ML kit. But what I really like about Microsoft AutoML is that you don't need to submit it to the cloud. You can also run it on your local machine. So yeah, if you want to submit to the cloud, sure, you have, as we had in the Jupyter's notebook case, you can use VMs to compute. But if you want to run it locally, which I think is really cool, if you have a powerful machine, you can run AutoML on your machine. The rest is the same. They're using a wrapper over the sklearn's AutoML model with pipelines and stuff like that. So your model, in the end, can be loaded in a simple Python code. So that's really cool. Aside from that, for the AutoML, you have a lot of analysis built in the platform. So they're using also a lot of insight, but that also Google offers. So you can try all the things. Then comes the packaging of the model, which in my opinion is really important. I will ask you a question a little bit later, but to give you some spoilers for that, packaging a model can be harder than you think, because you might be building with some version, and then when you're trying to learn another version, you have to redo the whole model because it's not compatible, and that's what packaging means. Also, it might be the case that you build a really, I don't know how to call it, unoptimized model, let's call it like that. It's way too big for the machine that you're trying to do, and in case you're building neural nets and you don't have experience or you don't know optimization tools, the neural nets might not necessarily need the whole setup. So you might not need all the neurons, you might not need all the connections, and in that case, the net that you're needing later might be more than you need, and the wider the net is, the more resources you need. So at some point, you might need to optimize your net. For model packaging, each service, basically, if you're reading the documentation, has a way of storing your model, exporting your model, or later reusing your model, as I said, with the ML Studio. You can load the pickle model, or you can use that model built in the system and then do an API over it. Now for the validation of the model, since most of them are using Python, you can validate them with all the SK metrics. You can validate them. AutoML has also built-in validation models because they are pipelines and stuff like that. So this part is pretty much done by everything. Now deploying the model, that's I think the hardest part. At least it was for me. So deploying the model means giving the model to other people. One option would be saving the pickle, the pipeline, the zip, the whatever, and then people using it. But then it's not necessarily easy to use for them. So I looked for solutions in building a RESTful API over my model. So basically people being able to call predict or fit over it, and then just being able to use it, not necessarily knowing what I did. So the black box principle. And I saw Flask, and somehow the setup was not working on my PC. I wasn't able to export anything. I wasn't able to expose my port. So I kind of gave up for that. And then I find that cool thing with AutoML and built my model, again, a pickle model. And it was a little bit better than mine because it uses some optimizers at the beginning. And then I saw, okay, what does Microsoft Stack also have? So, okay, it has ML Studio. Let's go to ML Studio. Can I load the model? Sure, I can load the model. And then, of course, since it's Microsoft on one side and Microsoft on the other side, it's really easy to import it and load it because the tools are compatible with each other. You might have surprises if you're running a model on Python with one version of a lib. So check always the versions, and then trying to load it on Azure. Azure won't necessarily have the latest package at the moment that you want. So if your intention is that to train your model locally and then load it on Azure, make sure that the libs have the same version, because then when you try to unpack a model, if you don't have the same unpackaging version, it will say that it can read something and basically you have to retrain everything. And that might be a lot of bad resources. And then when you monitor the model, it's basically the framework that deploy the model task. So if you deploy it in Azure ML, you have a lot of resources for monitoring. If you use Otaml, you can later get the initial insights and then pack them with your new data from the service. So with the new predictions and the new inputs, and then retrain it. So it's really important that you monitor to see how your model behave, because at some point you will see that you didn't test it enough and you're getting a lot of, let's say, weird for your model input from the user, and it doesn't know how to behave in that particular subject. And then you have to retrain the model. So for those of you hoping that you build your model this year and then 10 years later you can still reuse it, it won't happen. At best would be to collect the data each 3-6 months, and then based on the current state of the art, on what tools you found out, you might need to retrain your model, combining the initial data with the new data, or even combining your model with some other models. So for those of you who used AutoML, I think you saw that in general, the winning classifier or stuff like that is an ensemble. Ensembles use more than one classifier. So for example, in an ensemble, you have a regression, a random forest, separator, SVM, and then they vote. And based on the type of the classifier, the vote is quantified in one way or another. And then the winning vote says the class. So usually your best model will be multiple models glued together. So you might be also trying to combine that. And combining neural nets and standard models is a cool thing that you can also try. And now those are the links, but everything I said can be found. I still have 3 minutes. What I want to show you is the custom vision, because I think it's a really cool tool. So basically, let me zoom in a little bit, because I know it might be hard for you to see. So you're going to need an account. For this, a Microsoft account. I think they still have some free trial models. But then you can build a project and then choose either classification or object detection. For classification, you can either have the multi-label or the multi-class, and as you can see, they have domains, so it can be either a general model or it can be specialized. You can learn more about how you can pick your domain, but it's interesting to know that they already have specified models on food, landmarks, retail, and stuff like that. We don't know what the state of the art is, so it's not public what they're using behind the scenes, what type of neural nets, what architecture, whatever. But they're having really good performance. And as I told you, 15 images in order to classify something, I think it's gold. And then also for object detection, they have the general models and then some specialized models. The difference between general and compact, in a nutshell, is that the compact model is made to be later exported, as you can see, to be used with TensorFlow, Core ML on NX, or some specific toolkits, which means this later can be packed and used on a more compact system than a PC or a cloud-ready machine. Okay, so let's now move to the Q&A session. This is a cool image from one of my demos. Basically, people are afraid of AI. But even with the greatest tools, if you don't know how to use it or do common mistakes, because you can have common mistakes, your powerful neural net will manage to classify your cat as your dog. And in the project that you saw in the portal, I did that for a demo, and I didn't purposely build it wrong. I built it as good as I can, and it backfired on me. But I know the common mistakes which I did, and sadly, on another demo, I managed to build it properly, and then it worked. So most of the times it works, but when it doesn't, it's really important. Then you know why and how to fix it. So thank you. And now let's move to question and answers. I don't see a chat, so I'll have to ask you to speak or someone to select them.
Okay, thank you, Alexandru. So if you have any questions, just raise your hand, and then we will allow you to ask your question. So if you have any question, you can raise your hand.
I see two hands. Two hands. I think it's better for you to pick because probably I'll also misspell the names.
If you guys have any questions, you can ask.
Hello.
Yes.
I have a question. Actually, the speaker mentioned that there were some modules where we can drag and drop, and it was some kind of functionality he was trying to present. I couldn't get the idea of what he was trying to say. What was that?
So in Azure ML Studio, I'll share the screen in one moment. Okay. So Azure ML Studio lets you build AI using drag and drop and custom modules, as you can see here. Basically, you say, okay, I'll have an input. I'll edit the input a little bit, so I'll move some columns, I'll split some columns. Then I'll project the columns, split them, and then do classification, and then score the model. So instead of using Python to do each step, load the data frame with pandas, then edit the columns with mapping, then projecting the columns again with pandas, and then loading the scalar model to make the boosted tree. You'll be using them as modules. So I don't know, small components, and then just bind them one another, and then just select some parameters, and then ML Studio will do the magic for you instead of you writing code. But that means your whole task needs to be done with standard models. You need to know what machine learning studio components are available are.
Thank you.
You're welcome.
Have any further
Hello.
question?
Saad, I have a question.
Yes.
Alexandru, first of all, thanks for your precious time. And I want to say, ask a question that I completed learning path of Microsoft Cognitive AI Services, and I experienced that it worked good with small data set. So can we consider that if we used Microsoft services, then the need of huge data set eliminated, or should we always prefer large data set?
So cognitive services are already trained. So that means you don't necessarily need to have a huge data set. You can customize it with smaller data sets. But in general, the role of neural nets is that the more examples or the more data you have, the better it will behave. So when you start moving from already built models like cognitive services, and then you combine them with something else, ML models, you need to have better or larger data sets prepared. So if you're just going to use cognitive services for the customization task, you don't necessarily need a huge data set. But then if you want to move into the ML field, you'll need to prepare some large data set Not necessarily for now. So the first model might be good with a smaller data set, but in time, if you want to make it better and better, it will need more data. Tesla is learning continuously, it won't stop.
Okay, okay, thanks.
I have a question. Can I ask?
Yes, you can ask.
Uh, Thank you, Alexandra, first of all, for your precious time. And my question is that while talking about the professional life or while talking about the professionalism, which models would you prefer, a drag and drop model or the coded one model?
Depends on the task. It strictly depends on the task. So if it is a standard task like classify this, and I know that the state of the art is already built and is in the Microsoft ecosystem, I'll take 5 minutes to drag and drop the whole modules and done, rather than write Python code 1 hour and maybe have a typo and then train for 5 hours and then see that my model is bad. So depending on your task, you need to know what's better for you. In general, I try to write or drag and drop as bug-free as I can. So at the end of the day, nobody will ask you if you wrote 10,000 lines of Python or if you drag and drop 3 modules, if it works.
Thank you so much.
You're welcome.
Okay, I think that's it for questions. If you have any
Sir,
questions, yes.
I have a question. Actually, I have attended the Microsoft One More workshop online. They give us credit for VM. Now the credit is over, and I don't know how to use the features of VM again. Is there any way so that we can earn credits or the?
Yes, Rimsha, you can contact me for if you want further Azure credits. So I will provide you further Azure credits.
Excuse me, my question is from Alexander.
Yes, you can ask.
Yep.
You discuss one thing is classification and other is object. And classification, we do classification on the basis of, I don't clear this concept. Can you repeat?
Can you ask it again, please? So what you're asking is the difference between classification and detection on the custom vision?
Yes, you discuss the classification in the interface of AI. Classification and other thing is object, something like. So we do classification on the basis of.
Okay, so classification means seeing something. Let's say, let's go with images because that's easier. So when we look at something, we try to give it at least one label that we know. So if I look straight right now, I see my laptop, and I can say it's a laptop because of my knowledge of what laptops are. So this is classification, trying to give a label to what you're able to explore. And then object detection means I already know some labels. So I'm looking again and I can see the laptop, but then it means I have to describe where the laptop is. So I already know that, okay, this is a laptop, the task is not done. So it's first the classification and then mapping the laptop. Okay, the laptop is on my desk. So this is object detection. I can say, okay, I have a laptop. This is just classification. But then I can say the laptop is on another object and that object is a desk. So it's a multiple step classification. You can think it like that. And Microsoft is giving those two basic features for custom AI because those can be customized as you saw the models. There are some models that are, in the case of detection, they detect objects on shelves. So they have, if you go to the supermarket, you can use that custom model to detect your brand. So for example, you're a Coca-Cola seller, you want to see where your products are on the shelves, and you can use your phone with that custom model to see the exact positions of your product on the shelf. And that's really cool, rather than, for example, managing to detect cats and dogs in the pictures and their position. That can be done with a more general model. but then you'll have a specialized model to detect branded products. I hope that answers your question.
Okay, thank you.
We are going to take last two questions. So if you have any questions, so
Well, I also have a question. May I ask, please? Hello.
yes, you can ask.
Okay, my question is that how to join Microsoft, like for internship of machine learning, or if you want to join as a data scientist intern, like what academic credentials are required for it?
So you can either be an engineer in the a software engineer on the machine learning side. For that, you don't necessarily need high competency in AI, so you don't need necessarily a PhD or a master's. You need to have knowledge and the ability to map that knowledge to more practical domains. So, for example, going from the state of the art in recurrent neural net to some RESTful API. You have job descriptions for each job also if you apply to oncareers.microsoft.com. But if you want to be a scientist, you'll have basically to have scientist certification, and usually they're taking at least PhDs. So if you're on the PhD on the AI side and you want to apply for Microsoft, you can either go on the classical job, but at some point they also had openings for research. So if you want to do your PhD research with the company, so your thesis is more practical, you can also go with a company and then do your research with them. But usually you have job descriptions on the Microsoft side for all the credentials that you need.
All right, I got the answer. Thank you, please.
You're welcome.
I have a question.
Sure.
Can I ask?
Yes, you can ask.
Yes.
Okay, my question is that like many of the people are trying to learn machine learning nowadays because very hot topic in the industry. So what would you prefer, like how much certifications or how much knowledge do we really need to recall ourselves as a machine learning engineer or to apply for some particular job? Like there are many certificates out there and people are doing like that in an enormous amount. Like every other person is having like almost 3, 4, 7, 10 certifications. So what should be the minimum amount of knowledge or certifications or minimum threshold that a person should have so that they can apply that knowledge or consider them as a machine learning engineer and apply for jobs or internships?
That really depends on to who you're applying. For example, I have only one certification because I just needed it, and in my country, in Romania, the certifications are not necessarily important for the research domain. In our um, in our country, it's more important to have academic research. So, for example, publications, and that's what I'm aiming for. But in general, people will need to know your skills. You can show your skills through certifications. You can show your skills through competitions. You can show your skills through research. So depending on what you're aiming for, and you need to see what each job or position requires, because maybe they want hackathons on AI. There are a lot of hackathons. One Kaggle competitions. I saw job ads based on my Kaggle competitions. They can also ask for papers. So if you want to remain in the academia, you have to score uh, a research score based on how many publications you have, how many journals, how many stuff like that. So it really depends on what you're trying to apply for. You can name yourself a data scientist at any given moment because um, that's your knowledge. Based on that, you'll have a different level, and don't be afraid to apply for jobs that don't necessarily you match the exact criteria. You'll get feedback based on what you need to steal more, if you need to steal more, or maybe you'll be the perfect fit. My encouragement is that you look on Kaggle for competitions because you have a chance of winning them and they have money. There are real world appliances, so you won't learn something just for the theory. You learn and solve some real world problems. And if you don't know how to start, most of the competitions and the ongoing ones have already done notebooks, and then you can inspire from them and see how this task was also from other people, and then you'll get some insights and how you can start on that. So I don't know, 1,000 licenses certifications minimum. I don't know. I have one, and I will apply soon for a PhD in some other country because I got the invitation. So it's up to you how you show your skill basically.
So basically, if you have like 3 or 4 projects, good projects, then it would be enough, even if you don't have any certifications, right?
Yeah, yeah, yeah.
One more question.
Okay, thank you so much.
You're welcome.
I think we have to move on to next session. So if you have any further questions, you can contact.
One question. May I ask?
So it's last question, so we have to move on to further. So kindly ask Rutul.
Okay, you talked about Kaggle competition. They are merely for increasing the accuracy of algorithms. Like if you have predicted some model and it has accuracy, then the latest one. So you will win that competition. Such sort of competition.
I
I couldn't understand that.
I didn't heard you well. If you could please drop me an email, so or drop me a message.
So let's next session. So if you guys kindly please mute everyone. And if you have any further questions, you can contact at Alexandru on his LinkedIn. And thank you, Alexandru, for this wonderful session. It was really an
Thank you for
informative
having
one.
me.
Yes, thank you for that wonderful session. So
Have a
it's
good day.
glad. Yes, thank you. Everyone. So let's move on to our next session. Fahad, can you share your screen? Fahad, are you there? So our next session is on deepfakes explained. Is by Miljan Djordjevic. So introduction about him. So he is a computer engineering student at University of Belgrade, Serbia. He is also a GSDC lead at University of Belgrade for 2020-21. He is a ex-machine learning intern at Microsoft. His experience is with deepfakes, FPGA programming, operating systems, and web development. Before starting his session, most of you were asking about the attendance link for today's session. So, Fahad, can you move on to the next slide? If everyone missed the attendance, they can like mark the attendance. So, can you move on to the next slide, please? Okay. So, if anyone missed today's attendance, kindly go to bit.ly/MLSA 2. So, kindly mark your attendance here. So, take a screenshot if you are feasible. So now let's move on towards our session. So Miljan, are you there?
Yeah, I'm here. Can you hear me?
Yes, we can hear you.
Okay.
Kindly share your screen, Miljan.
Yeah, just a second. Okay, so can I start?
Uh, just like the screen taking some time.
Okay.
Yes, it's quite visible, so you can start.
Okay, so hi everyone, my name is Miljan Djordjevic. I come from Serbia. I'm the lead of the Google Student Development Club here, the University of Belgrade. Can you just can someone confirm me that you hear me well, because my internet connection is not the greatest?
Yes, you are quite audible. You can
Coming
continue.
clear words.
Okay. Okay, so
Basic experience.
okay, so I'll talk something about deepfakes. I've come across deepfakes several times in the past. I've worked something related. I've worked on something related with the concept of deepfakes during my internship at Microsoft. I'll talk a little bit about that. I've worked on a scientific paper that did something with deepfakes in the November of 2019. I'll start with that. I'll just give you an overview of what I did. I'll give you an introduction to what deepfakes are. I'll showcase some of the deepfakes I've made myself, and I'll talk a little bit about two models for deepfake creation that I've worked on that I've worked with in the past. So I'll just start off with this presentation, with the presentation that I used when the presentation I used to showcase the results of the scientific paper I've worked on in the last year. I don't know why the presentation is stuck. Just a second. Okay. So I've worked on this paper titled Deepfake Video Analysis Using Shift Features. So this was a deepfake detection algorithm I've worked on. I'll just briefly go over the algorithm. I'll use this presentation to just give you an introduction to the field of deepfakes and what deepfakes are. So deepfakes are basically audio and visual forgeries. So they are audio and video materials that were created using ML algorithms. So they're basically, you have probably seen a bunch of examples online of Trump or Obama or some other famous person saying something that they did not say, and you probably noticed that the videos weren't that good. So you can see, let me just share you a single example. Okay. So you can see this. So I'll showcase some of the deepfakes I've created in the past. So here is a default example. So
Sorry
we
to
have
interrupt. Miljan, your first slide is stuck here.
yeah.
Are you on the first slide?
No, I'm showcasing. I'm showcasing my. One second. I'm showcasing. Let me just find the right tab. Okay, so I'll share my entire screen. Okay, so can you see this?
Just wait a second.
Yeah.
Yes, now it's visible.
Okay, so here is an example of a deepfake. So, do you see the video?
Yes, we can.
So on the left you have the source frame, in the middle you have the driving video, and on the right you have the resulting deepfake video that was generated using the picture on the left that was combined with the facial motions of the person in the middle to create the video on the right. So you can see some artifacts that are not natural and that can actually make deepfakes noticeable, but that's sometimes more and sometimes less noticeable. So an important problem when talking about deepfakes is their detection, since the creation algorithms are becoming better and better. So the problem of detecting them and actually having an algorithm that can be used to actually confirm the originality, the actual credibility of some on some video you find online is becoming more and more important. So I'll show you some other deepfakes I've created. So this is me being driven by Donald Trump. You can see how my face is weirdly shaped and my head is kind of, when I tilt my head, you can see the artifacts, the unnatural movement that can be seen by the human eye. And this works better. The entire deepfake creation models work better when the faces of a driving and the source person are similar in shape. And here's some more examples. As you can see, it works, but it's not perfect, and it can be detected by the human eye. And some of the, I can showcase this as well. This even works on cartoon characters. So as you can see, we take a source frame that is from a cartoon. We take a video of a real person, and you can see the motions translated in the video on the right. So I'll just go back to the presentation. Those would be some of the examples of deepfakes. So just the people that don't know what deepfakes are have an overview of what I'm talking about. So I'll continue with the presentation. So in this paper, I've worked on a detection algorithm for deepfakes, and it was based on SIFT. SIFT is a computer vision algorithm developed in 2000 or 2002, I'm not sure. So we've tried using that that algorithm to detect deepfakes. So just an introduction. So deepfakes and deepface is I think Facebook's algorithm. I'm not sure. I think it's that neural network, face detection neural network that has like 99%, 98.75% accuracy. So deepfakes are. What are deepfakes? Why are deepfakes called deepfakes? So deepfakes surfaced on the internet in December of 2017. The original author of the original deepfake was a Reddit user with the username Deepfakes. So basically, they are called deepfakes because of the Reddit user that created the first one. They were really rough and really bad in the beginning, but as the technology develops and as the models become better and better, they are harder and harder to recognize, to differentiate from the real videos and real video and audio material. So here are some of the deep fake algorithms you can find on the web and some of the generation tools. You can basically now download a mobile app to that will allow you to create deep fakes in a couple of clicks. There are over 100 repositories regarding face swap, which was
Are you on the deepfake video analysis slide?
No, I'm on PowerPoint.
It means it's showing deepfake video analysis using SIFT features. Are you on this slide? I just want to confirm.
I am on the fourth slide of that presentation.
Not start.
Yeah.
Can you please check this?
I didn't get you. Could you repeat what you said?
I just want to confirm that you are on the slide deepfake video analysis.
No. Let me see.
Showing that slide.
No. I'm on the fourth slide. I'm on the recently introduced deepfake generation techniques.
Something?
Yeah.
I
guess there are some buttons by which we can navigate forward and backward.
Yeah. Am I now on the different slide?
Yes, you are now introduction slide.
Recently introduced deepfake generation techniques.
Yes, it's deepfake and deepface. It's on first slide. It's showing.
Okay.
No, it's recently introduced deepfake generation technique slide.
Okay. So that's where I should be. So there are several very famous deepfake generation models that were introduced in the past couple of years, like few shot facial models. I don't know what it's called, what that one is called. Oh, this one, few shot adversarial learning of realistic neural talking head models, which was revolutionary. It was introduced in the May of 2019, and it was revolutionary in a way that it introduced a model that worked that could work on only a couple of images. In the past, you had to have a larger base of pictures that would be used as source images to extract the face that would be put on top of the driving vector that would be extracted from the driving video. And with this model, we got a model that could do the same thing using a single source image. So, for example, this was used to generate deepfakes of from famous paintings, like this. You've probably seen this. So we can basically have videos of people that lived in the time and when videos didn't exist, for example. So those are video forgeries, and I'll encourage you to check out Lyrebird. This link, the third link on this others tab down on this slide. It's basically a Canadian startup that deals with audio deepfakes. You can record yourself talking, and it will train.
You are muted.
Okay, why am I muted?
Yes, you can start, Miljan.
Yeah. So did you hear me when I talked about this few-shot adversarial learning of realistic neural talking head models?
No.
No.
You are again muted, Miljan.
Yeah, I don't know why I'm getting muted. Who is someone unmuting me or what? Let me check. Okay, am I muted now? So
Yes,
in
we
the May
can
of
hear you.
okay, in the May of 2019, you didn't.
I can't hear you.
Why is this happening?
Am I back?
Yes, you are back.
Okay, so someone was muting me, and then I think I lost my internet connection.
muted.
So I'm not muting myself. Someone is muting me.
Jan, you are again muted. Saad, can you take control of all mics?
Can you hear me?
Yeah.
So, so someone was muting me. Someone is constantly muting me. I don't know who has the rights.
No, Miljan, it's some, I guess, technical problem.
Okay.
Can you please continue?
I mean, yeah, but I'm getting muted on like every 5 seconds.
I think it's resolved now. Sorry for inconvenience. Kindly continue.
Okay, so what slide am I on right?
You are again muted and you are on first slide.
First slide, okay. I'm not muting myself, so it's either a technical issue or someone is muting me. So let me just exit the PowerPoint. So I'll do it like this. I won't change the slides. You change them for yourself. I'm currently on slide 4. Recently introduced the deepfake generation techniques. So in May of 2019, there was a by the Samsung Institute in Moscow, which introduced a model, deepfake generation model, based on the input, based on. I'm still getting muted.
I think there is an option and
There's
someone
an
is
option.
doing that.
What did you say? There's an option.
There is an option of someone is doing that.
Yeah, someone is doing that. Yeah.
Excuse me. The solution for this, the organizer make attendees to all of you.
Sorry for
Uh,
inconvenience. Saad is resolving the issue. Kindly wait for some time.
Okay.
Is actually, I think, as admin rights, he or she can take control.
To be honest, this is such a childish act.
I think the option of mute all is gone, so you can continue.
Yes.
Yeah, okay. So on the slide 4, recently introduced deepfake generation techniques. So in May of 2019, the Samsung Institute in Moscow introduced a model. Researchers there introduced a model which could generate deepfakes based on a single image. So this was used to generate deepfakes of famous paintings. I don't know if you can see the slide I'm on right now, and it's not displaying the video as far as I can tell. So those would basically be videos of people that lived in time that in times that at which the video technology didn't even exist. So this was revolutionary back in 2019. Something that I would encourage you to check out is this artificial voice generation Lyrebird that you can see on the 4th slide. Recently introduced deepfake generation techniques under others tab. So the Lyrebird is a Canadian startup dealing with audio deepfakes. So you can basically register on their website and record yourself speaking. And they use that data to train their models and basically replicate your voice. This can be basically used to create a virtual assistant that has your voice, and it works quite well. So deepfakes are really easy to create. Now you can basically, here's the alpha deepfake web, the one of the websites that you can use to generate deepfakes. You can go here, and as you can see, it takes about 30 minutes to work with. You can upload your images, and if you don't want to retrain their models, it can take up to 30 minutes to generate deepfakes. And if you want to retrain the model for better results, it takes around 4 hours. And here is the pricing, $2 per hour. And this was kind of useful a couple of years back, but now I'll showcase one of the papers, one paper that was okay. So I've lost control over the presentation. So I'm on slide 6. This was useful a couple of years back, but now you have models and call-up notebooks that allow you to create deepfakes in a couple of minutes. Much easier than this, and it's completely free. So now I'm on slide 7, SIFT features. So I'm not gonna go into detail with this. This is not the point of the talk. SIFT features SIFT is the scale invariant feature transform. It is the algorithm that detects features in a image. Features are points of interest like edges, corners, and stuff like that. It can be used to extract important information from images, and more importantly, it can be used to create a map of features for one image that can later be used in the matching process. So we can have two different images and we can match them for similarity, and basically use this to detect objects in an image. So our idea with this algorithm was to use SIFT to compare successive video frames in deepfakes and in original videos. So we used pairs of deepfake and original video that were the same video, just one was manipulated, like you'll see the examples. Something like face was the the driving video was the same, but the source video in the deepfake was changed. You'll see examples. So we use this to compare matching percentages between successive frames in original videos and in deepfakes to try and see if there is a something or something that we can extract from this data and maybe detect deepfakes. So SIFT features, I'll just go briefly over how they work. So, I mean, I don't have to go these dips. I'll just skip over this part since it's not that relevant. So basically, you create this pyramid of Gaussian blurs over images. You scale that down. You keep doing that. So I'm on slides 9. Can you are the slides changing for you?
Yes.
Okay. So you create this pyramid of Gaussians. Basically, you scale down image, then apply Gaussian blur, and continue doing this. So in the final result, you have this pyramid of blurs, and you subtract the adjacent ones to create those maps that actually outline the edges. And you keep doing this for all of the pairs, and you create a bunch of those new thresholded pictures. And in the end, you use the scale up and scale down with the current scale to actually compare the pixels. And if the pixel as you can see in this picture, if the pixel in the middle scale is the local extrema between those 27 actually pixels, then it's considered a key point and is considered and will be considered for a feature later on. So we basically do this. You probably can't see the dots on this white dots on this image, which are potential key points that this part of the algorithm will actually extract from the image. And this is repeated on each scale, on those 4 scales that you saw before of the Gaussian pyramid. And then you remove the outliners, the key points that have the intensity that is lower than a certain threshold. This is thresholding. And then additionally, you apply several different. I'll skip over this because it's just too complicated for this and it doesn't contribute much to the talk. You have several other steps that remove a lot of those key points previously detected by subtracting those Gaussian blurs. And in the end, you get something like this. So out of the image on the left, you get the image on the right, which has graphically displayed the key points detected with their intensities. So the size of the circle is their intensity, and alongside intensity, you can see orientation. Your orientation is based on the pixel gradient in a certain area of the image. So that's basically the gist of how SIFT works. And now what we did, we basically took successive frames from an image. I mean, here is an example of how that SIFT works in real time. I mean, is video loading? Can you see the video? I think it's just slow. Yeah. So here is an example of the Dell logo matching in real time. You can see it basically takes the image from the camera, the input from the camera, and tries to find the features, and then matches those features with the logo on the right. So you can see when I move the camera closer to the monitor, you can see the matching goes up. Okay, so here is an example of that with the static images. So basically, comparison to itself and matching percentages when you rotate. So scale invariant feature transform. So this feature detection algorithm is famous because it's scale invariant, rotation invariant, affine transformation invariant, illumination invariant. So basically, you can rotate images and it'll still detect them. It'll still work when matching. When used for matching, you can scale. You can use. Here is an example with the real life and just blank logo, and the matching percentages. And this can be used to detect smaller objects in a bigger image based on those feature matching. Based on that feature matching that I showcased earlier with that video. So now what we did, we basically compared successive frames in deepfakes and in real images, and we tried to see where is which video has successive frames in which video are more close to each other. So basically the idea was deepfakes are not that good, and you can see the artifacts, and the face is kind of like jaw and eyebrows can act weird. And basically if you match successive frames, those spikes in artifacts can be detected. So this was the idea behind this. So here are on the left you can see the videos deepfakes, and on the right you can see the matching percentages generated, and a couple of other videos. Let me just change the slide. So here you can see again they differ, and we've proven that the matching percentages in deepfakes are higher than in original images, and this was done on a small data set, and further research would include increasing the data set. Something happened on my side. I've lost the presentation. Okay, I'm frozen. Huh. Okay, so I'll share my screen now. Okay, can you see my screen?
Yes, we can see.
Okay, so I don't know what happened, but my presentation went black. Anyways, so I'll just showcase some of the deepfake creation algorithms I've worked with in the past. So it's this one. I'll start with this one, X to face. So it's basically a weaker algorithm that was developed, model that was developed in 2019 by researchers at the University of Oxford. So I'll just briefly go over the idea. You have here is the architecture. So it's basically two pix-to-pix networks. You have the embedding network and the driving network, and they are basically completely the same. They only differ by the amounts of the number of nodes in individual layers, and the driving network has this driving vector in the middle. The pix-to-pix network is encoder-decoder, uses encoder-decoder architecture. So embedding network uses a bunch of source frames to create the embedded face. So the embedded face is the frontalized human face that it will later use it will use that and combine that with the driving vector it gets from the video to generate new videos. So here are examples of just a second, embedded faces. Okay, so this doesn't actually have embedded faces in it. So never mind. They are basically frontalized and highly distorted human faces, which the embedding network generates. And let me see if there are examples here. Here. So this is, for example, an embedded face. It's basically squashed and like squarified or whatever. And here, for example, and that's the output of this first network. That's the output of this first network, embedding network. We get this, and then we take the driving network. We take a video, and we push it through the driving network. Actually, not the video, but we separate. We extract all the frames from the video, and then for each individual frame, we drive it. We push it through this driving network, which encodes the image into a 128 dimensional vector that can then later be used and decoded into this orientation map that can then be projected, that can then be used for projecting the embedded face onto and to generate the new frames. And basically by stacking those frames we get a deepfake video. And something more about the architecture can be found in this paper if you're interested. It's not that good. The results are not that good, but they were better than the state-of-the-art deepfake generation models at that time, as you can see here, cycle-GAN X-to-face comparison. And about the yeah, it also works with audio signals. So they've tried using not only video material as the driving input, but also audio material. So you can basically generate videos based on pitch. So it would manipulate mouth movements. It will try to predict mouth movements based on the audio recording. And at the back section of this paper, you can find the detailed architecture used, like pix-to-pix network, and how it was modified for this model. Basically, embedding network and driving networks are completely the same. With that, the embedding network has those skip connections between those matching layers. So it works faster. So that's it from this paper. I'll show you some of the examples of deepfakes I've generated using this net. It's not that good, as you can see. Can you see the video?
Yes.
Yeah. Okay. So it's not that good, as you can see, but it still works. Here are the better examples. So the model uses Vox2Celeb for the Vox2Celeb dataset. So when it's when both driving and source frames are taken from that dataset, it works better, as you can see here. Okay, this is just frames are off, frame rate is off, and these are some of the ones that I've generated myself, and they use the driving here is from my webcam, and the source pictures are cartoon characters or whatever. So it does replicate the face to a certain extent, but it's quite bad compared to the deepfakes I've showed in the beginning, as you can see. So this is really bad, and I'm just showcasing this so you can see how far deepfakes have gone from 2019 up to this point. Earlier this year, a paper was showcased, first order motion model for image animation, that worked wonders regarding deepfakes. It's basically the easiest possible the easiest possible way for you to generate deepfakes. You can find the Google Colab you can find the GitHub code here. I'll share the links somewhere later. So they've the authors of the paper have created a Google Colab that basically anyone can use and generate their own deepfakes. So you basically just connect to your Google Drive, you insert driving video and source picture, and it will generate deepfakes for you without paying anything, and without the hassle of waiting that I've talked about in the beginning, with that 4 hours training with that website that was offering training for $2 an hour. And here are some of the examples. This network is much better than X2Face, and here are some of the examples, some of the videos I've generated using this. So okay, this is from the Vox2Celeb, so it's not that good, but you can see that mouth and eyes and everything is much better than the videos I've previously showcased. Yeah, and it works on cartoons as well, as I've showcased in the beginning. It works quite well. It replicates mouth and eye movements. So the experts in the field were saying that deepfakes will be undistinguishable from real videos in 6 months, and that was like, I think, something more than 6 months ago. So basically, they're becoming better and better, and that this is becoming a problem. So the problem of finding the algorithm, universal algorithm that can detect any deepfakes is more and more important, becoming more and more important. And there are several different approaches to this problem, some of which are just generating neural networks or any other algorithm that can detect deepfakes, like on the software level. Another approach would be adding some type of MAC or something, some encryption, some signature to each video on the internet, so its validity can be confirmed, and that's another one. And the third method would be using blockchain to actually just validate the source, the video source. If you find some video on the internet, you can validate its source using blockchain technology. That would be the third method of fighting visual forgeries online. There's not much head movement here, so those deepfakes don't open their mouths. Yeah, I think that would be it from me. So if you have questions,
We are open to questions. So if you have any questions, you kindly raise your hand, and we will allow you to ask your question. Yes, Kenza, you can ask.
Hello.
hey,
Actually, I have a question that I want to ask. Why do we even create deepfakes if we have to detect them, and it's like a problem for us, and we still create them, and then we detect them, and then we are asking for solutions. Why do?
why do we do both things? So basically, here is an example. In Ghana, the African country, there was an example. There was a situation, I think last year or something like that, when a deepfake of their president was put on the national broadcast television, and this almost caused a how do you call that, the attack on the state, the I don't know what it's called. It almost caused a revolution. So you can basically have some famous politician say anything or do anything, and you can put that online. And several times in the past, like with Facebook, some videos of famous politicians were posted on Facebook, and a larger audience of people were fooled by them. They thought they were real. So you can see the potential dangers with this. When you think about the fact that anyone can be, you can basically generate a video of anyone saying anything. So if it's an important person like Donald Trump or someone else, and if it gets broadcasted on a platform with wide enough audience, it can cause real damage. And basically, the people developing deepfakes are mostly researchers, but many of them have malicious intentions. So it's basically a war. Some people are trying to create deepfakes that are better and better. and some are trying to create algorithms that can detect them and potentially reduce the damage that could be caused by them. Some of the reasons why you would like to create deepfakes is perhaps video production, because they speed up the process of producing video material uh, like exponentially. You have basically automated the process of extracting facial expressions and then using them. If you have done something in Photoshop of this kind in the past, you know how difficult this is, and they completely mitigate this cost, and they automate the entire process. And in the far future, when they are good enough, you can basically use them to create movies or whatever, and you can see the potential good in them. But again, if they are used in for a wrong purpose, you can see the actual potential damages. So that's why we actually have the both sides, both detecting and creating. Okay.
Yes.
Shahir,
Uh,
can
Oh, okay, Sada. Miljan, thanks for your talk. I really enjoyed even after many hurdles. But I have a question. As a researcher, what kind of technology you consider deepfake as helpful or harmful? It seems be more dangerous to human because it can deceive anyone and even without judging proper judgment. So, what kind of technology you consider this as?
I mean, you can. It's basically not up to the technology, but up to the user. So, for example, you can find that Lyrebird, that's Canadian startup I showcased earlier. So it can actually replicate your voice so well that people that know you will get fooled by your voice. So basically, you can take someone, then get his samples of him talking, enough samples to train the Lyrebird model, and then use the trained model to generate new lines, something that he didn't say, and then use this to make phone calls and actually uh, instigate some damage that you can't actually control. So basically, there were attempts in the past. There were tests in the past, and people were actually fooled by the artificial voice. So you can see if something like this, if there's some controversial thing happening in the video, and if it's broadcasted on like live television, it can have severe consequences.
Then I think that it should be restricted because it has I think a lot of damages that it can do to human
Yeah,
being, destroy the privacy of a person.
yeah,
And
but you can't restrict it. You can just fight it. That's why we have the detection algorithms. You can basically go on Reddit and see how much material there is actually fake. And basically, what happened with Facebook, for example, Facebook has banned deepfakes in the past. I'm not sure about Facebook, but many sites have banned them. And although they have banned them, and although they've integrated detection algorithms on their websites in the past, you can still find deepfakes there. So it's just the war that's going on. And basically, Facebook, I think Facebook banned them for some period of time. I don't know if they're still banned when videos of AOC and Donald Trump, and I don't know who else got posted there. As I said earlier, when the audience was fooled by them, and they banned them, but you can still find deepfakes, and even deepfakes with Facebook CEO can be found on Facebook.
okay. Muhammad Ali, do we?
Question:
Yes.
is it the same soft process that Apple is using in their emojis?
I'm not familiar. What did you say? Apples?
Apple emoji.
Apple? I'm
Yeah,
not sure
Apple has
about that.
introduced their emojis in their iPhones.
Yeah, emojis.
They're actually duplicating your face expressions in the cartoons and characters.
Yeah, that's probably based on this on same technology. I haven't seen that.
Okay, and I want to ask another question.
Yeah.
What softwares are required to make deepfake?
Software. So basically, for those two papers I've worked with, those two models, I can tell you. So the first one used, I think both of them were in PyTorch, Python and PyTorch. So basically, you can do this in TensorFlow, but for convolutional neural networks, I mean, basically everyone is switching to PyTorch now, and basically PyTorch. And if you just want to create your own deepfakes fast, I'll send you the link later. You can use this Google Colab I've mentioned before. It's basically 2 clicks. You just upload your video and image on your Google Drive. You connect Google Drive to the Colab, and it generates you deepfakes in like a couple of minutes. And that's it.
Sure, it would be helpful if you share the link.
Yeah, I will. I don't have access to chat right now. Well,
Yes, Miljan, we can take from you, and we'll share emails to all attendees.
Okay, yeah. So I'll just send it to Sad.
Sure, thank you.
So, do we have any further questions?
Miljan, I have another question, and I am interested to know the benefits that people can gain from this technology.
Yes, same.
Yeah. So basically, if you've seen so basically you can automate video generation process. So video editors have much more flexibility on how to create, and the speed of video creation is improved. You can potentially in the further future you can have movies that are generated like this, completely adversarial. And I don't know if you've seen this stock motion features footage, like stop motion movies can actually become can be extended to full motion using this technology. So this can be used to approximate the missing frames in a movie, for example. So basically, if you have cuts in the movie, this can be used to technology like this can be used to circumvent those damages to the video, stuff like that. And it can be used to generate automatic I don't know, like chatbots, for example. Right now you can actually have chatbots with actual human expressions and everything, like a full on video assistant that can talk with you. And this is if you were to create an artificial video each time for each expression and for everything manually, that would be like a lot of work. And this basically short circuits the entire thing, and you have full automation when it comes to this kind of video creation.
Iman, do you have a question? Kindly unmute your mic, Iman. Okay.
No, I don't have a question.
Okay.
It just got cleared.
Okay, great. So I think that's it for today. So thank you, Miljan, for this wonderful session. It was really an informative one. If any of you wants to connect Miljan, you can surely contact him on LinkedIn or Twitter. And thank you, Miljan, for this wonderful session.
Okay, thank you for your time, and I hope this was informative for you.
Miljan, we will take all the links from you so that we
Yeah.
can share with these attendees.
Yeah.
And yes, so that's it for Miljan's session. And Fahad, can you share your screen now? share your screen.
Sad, done. My screen is visible or not?
Can't see your screen.
Wait.
Yeah, your
It's
screen is
visible.
visible.
I can see the
Clearly
screen.
visible, Fahad.
Yeah, your screen is visible.
Right.
I think that's so. Fahad, kindly go to the attendance link. So if anyone missed today's attendance, so we are showing you the attendance link. Kindly mark your attendance, and Fahad, kindly go to the hashtags. Are you on the hashtag, Fahad?
Yes.
Okay, so everyone kindly uses hashtags when you are going to share what you have learned in this AI bootcamp uh, on the first day and the second day. Kindly mention what you have learned and what you want to pursue further. So use these hashtags for Microsoft Launch Student Ambassadors Lahore, IEEE UCP, IEEE CNAID, IIT ComSets, and Women in Engineering Lahore. So kindly share your experience, what was about these 2 days. And we have another simple task for you guys. Fahad, can you go to the last bootcamp slide? Are you on the slide, Fahad?
No.
Fahad, can you go to the bootcamp slide?
Done, Sad. I'm on the bootcamp
We,
side. Last slide.
Everyone, you have to do a simple task. Just take a screenshot of this whole, you can say Microsoft Teams. So take a screenshot of this and post it on social medias with the hashtags, what you have learned in these 2 days, and mention the communities from which reference you have joined this AI bootcamp. First Alexandru and second Miljan for this wonderful session. And your certificates will be provided you in 2 to 3 working days. We will email you all the links of the uh, resources and with the certificates. So thank you everyone for joining this AI bootcamp, and for all the societies. They have done awesome work in collaboration with us for this event, and we will hope you have learned something new in this AI bootcamp. So thank you everyone for joining, and Miljan for this wonderful session. Just take 1 minute
Thanks a
and
lot for arranging this beautiful.
thank you.
Yes, it was
Just take 1 minute of
extremely informative.
yes, thank you. Just take 1 minute of yourself to take a screenshot of this and share this on social medias. We would like to be a part of your what you have learned in this AI bootcamp. So thank you everyone for today's session, and I am going to end this in a minute. So everyone can kindly take the screenshot of it. Thank you.
Thank you, sir.
So I think you have taken the screenshot. So thank you everyone again, and we will hope you will join our future events. And if anyone wants to do further collaboration, or if there are any societies they want to collaborate with us, they can surely contact with us so that we can plan further events. So I'm going to end this session, and thank you everyone for joining. Allah Hafiz.